Hello, this is the Physics MC, and today's lesson we will talk about free body diagrams with vectors, net force equations, dealing with non-parallel forces. So let's do this example. What would be the third force acting on the system so that it would be in equilibrium? So here we have an object on the middle, and there's a force going up this way, 500 newtons, 30 degrees, and so 500 newtons, 30 degrees. We have a force going this way. It's 400 newtons at 33 degrees. So the question is, what third force would we need on this block to oppose those forces and cancel everything out? Basically, which third force, this direction, would we need to set this thing in equilibrium? So in order to do that, what we need to do is we need to look at this force right here, which was 500 newtons, at an angle of 30 degrees, and we have a look at this one, and the magnitude is 400 newtons, and an angle of 33 degrees, and we need to vectorize it. In other words, we have to make triangles out of it, because that's going to tell us the vertical forces and the horizontal forces for this block. So we can look at this force right here and make a triangle from it. There's a part that's pulling it to the left. There's also a part that's pulling it up and down. So the part that's pulling it up and down will be this side of the triangle. The part that's pulling to the left of this side of the triangle. The resulting force is 500 newtons. Same thing with this one. We have 400 newtons going this way. There's a part of that 400 newtons going up, and a part of that 400 newtons is going to the right. So when we solve using cosine and tangent and sine, we end up getting, because this is a 30-degree angle, that this side is 250 newtons, because the sine of 30 times 500 is 250. We use the sine because that's going to be the opposite side. This is the hypotenuse. Cosine of 30 times 500 is 433 newtons, up and down. For this triangle, we have cosine of 33 times 400 ends up being this side, which is 335 newtons, and the sine of 33 times 400 is 218, which ends up being this side. So really what we have is, this is a force point upward on this block. This is a force pulling upward on the block. This 250 newtons is pulling to the left. This 335 is pulling to the right. So let's redraw this diagram in a way that is a little bit more clear. Instead of using arrows or vectors, we'll end up just putting horizontal and vertical arrows. So we have this 250 newton pulling to the left, the 350 newton going to the right, the 433 going up, and the 218 going up. Where did these come from? Well, they came from these triangles. We got rid of this 400 and this 500 to make it more suitable to this object, because this is much easier to work with than those crazy vectors. Okay, so now we can look at a net force equation in the x and a net force equation in the y, the vertical. In the x direction, we have 335 newtons to the right minus 250 newtons, because they're going opposite directions. So we minus those. The difference between those is going to equal your force. You're going to have to apply a force on this object, a little bit more force to the left, because these two forces are causing it to go to the right. So your force has to go a little bit to the left. How much to the left? Well, whatever the difference is between these two, which looks like about 85. Now, with these forces that were already on the block, there's two vertical forces on there, 433 up and 218 up. That's going to give you a total of whatever that sum is, 218 plus 433. That's going to equal your force as well, except your force is going to go down to cancel out these two upward forces. So, revamp this. The net force in the x is 335 minus 250. That's going to equal your force up. All right, 651 newtons is your force, because that's what you need to apply in order to cancel out those forces from the previous problem. 85 newtons left, because without that force, it's going to go to the left. So your force in the x direction is 85 newtons. your force in the y direction is 651 newtons, and we got that from this concept. There was, I'll go back a little bit more even. This concept right here, this was 500 newtons. This is 400 newtons. Our force needs to be down this way. Down this way. How much down? Well, we already figured it out. We have to pull a little bit to the left. That's 85 newtons. That's what we figured out. And a lot down, which is 651 newtons. We figured that out. So we have to pull 651 and 85. Right. Resultant force is the hypotenuse of the triangle. We can get that from a squared plus b squared equals c squared. Let's go back a little bit. So yeah, this force is pointing up and to the left. This force is pointing right and up. So your force is going to have to be down and left. So I made a typo here. So your force is left and down. This force should be down. That's my typo. But regardless, the arrow is pointing up or down, we still get the same hypotenuse. It's just the direction will be down to the left rather than up and to the right, up and to the left. So using SOHCAHTOA and a squared plus b squared equals c squared, we get the resulting force is 657 newtons, and the angle is going to be the tan inverse of 85 over 651, or 7.4 degrees, left of straight up. Hopefully this helps, and that has been the Physics MC. All right. Have a great day.